All right, class, we're going to continue these notes on Lewis structures, and now we're looking at a few more example problems. So starting out with N2. All right, N2 nitrogen is in the 5th group on the periodic table, or group 15, which has 5 valence electrons. Multiplied by 2, get 10. Don't forget, we always need to do the math before we do anything else. So that's our number of available electrons. We've got 10 available electrons. The next step is the skeleton. So we need to decide what our central atom is. Since it's just 2 nitrogen atoms, this is really not a necessary step. We're just going to draw both of them and connect them with one line. There's our skeleton. Okay. After doing that, we want to make the outsiders happy, which both of these atoms are outsiders or insiders. In this case, there's no central atom. So we just want to use up all 10 electrons and make these atoms as happy as possible. So far we have 2. Let's keep going. We've got 4, 6, 8, 10. Uh-oh. Now we're out of electrons and it looks like they're not happy. Okay. So at this point we ask if we have any leftovers. We don't have any leftovers. We actually ran out. Then we ask if the atom is happy. It's not, or if this molecule is happy. Nitrogen's not happy on either side. We need to take a couple of those electrons and share them to see if we can make this follow the octet rule. So if we did that, then the nitrogen on the right side would have 2, 4, 6 still. But the nitrogen on the left side would have 2, 4, 6, 8. So the one on the left would be happy, but not the one on the right. So that means we've got to have the one on the left also share 2 electrons so that they can both be satisfied. So they're both going to do some sharing. We'll end up with a triple bond, or 3 bonds between them. This is what the final structure should look like. By the way, that's a much stronger bond because it's a triple bond. That comes into play. All right, the OH, or hydroxide, OH minus hydroxide ion. Okay, oxygen has 6 valence electrons, and hydrogen has 1. But don't forget, if we have a negative charge, that means we have extra electrons, so we're going to add an extra electron. Have 1 more electron than usual, so that's going to give us a total of 8 valence electrons. So I've got oxygen and hydrogen. Start with connecting 1 bond. Remember, hydrogen only wants 2 because it's an exception, but oxygen would like 8. So I just used 2 electrons. I'm going to keep going. 2, 4, 6, 8, and we're done. Hydrogen is happy because it's got 2. Oxygen is happy because it has 8. We used up all of our electrons. There are no leftovers. We just need to put it in brackets and write -1 because this is a negative polyatomic ion. Right, let's look at CH4. Okay, CH4, carbon has 4 electrons, 4 valence electrons, plus hydrogen has 1 valence electron, and we've got to multiply that by 4. So 4 plus 4 gives us 8 valence electrons. Which one's going to go in the middle? Well, we've got a singleton. Carbon is our singleton. It's also written first, so that's 2 clues that carbon goes in the middle. Carbon, and I'm going to write hydrogen 4 times because of that subscript of 4. So 1, 2, 3, 4. 4 hydrogens. All right, and we want to connect the central atom to each of the outer atoms with a single line to start with, and let's count. 2, 4, 6, 8. I've used up all of my electrons that I had available. So available, skeleton. Are there any leftovers? There are not, because I used all 8 of them. And then we ask if they're happy. Well, carbon wants 8, and it has 8 around it. And each hydrogen wants 2, which is exactly what each hydrogen has. Let's go on to number 16. NCl3. N is in group 5. Cl is in group 7A. So it's got 7 valence electrons, but we're multiplying by 3 because of the subscript. So I have 21 plus 5 is 26. Start with nitrogen as our central atom with 3 chlorines. So 1, 2, 3. 1 bond to each. That's 2, 4, 6 electrons. And we're going to start with our outer atoms, which is chlorine. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, which leaves us only 2 left. So we do have leftovers. Remember, your leftovers always go on the central atom. By the way, that actually makes nitrogen more happy in this case. We have 2, 4, 6, 8 electrons around nitrogen, and each chlorine also has 8 electrons around it, valence electrons. Go on to SO2. Sulfur has 6. Oxygen has 6 multiplied by 2, so that'd be 12 plus 6 is 18. All right, sulfur will go in the middle because it's our singleton, and then we'll have 2 oxygens. So that's our skeleton after connecting with lines. Now let's make the outsiders happy. 2, 4, 6, 8, 10, 12, 14, 16, and then we have 1 extra pair. We have 2 more. So to get to 18, you put that last pair of electrons on the central atom. That's what you do with the leftovers. They go on the central atom. Now this makes oxygen happy. Both of those have 8. Sulfur has 2, 4, 6, so that's not quite happy. So what we can do is pick from either here or here, and it really doesn't matter which one you do. And then we're going to move it down and make a double bond. So we're just sharing those electrons instead of having them as a lone pair. So this is what our final structure should look like. All right, then we get to OF2. Oxygen has 6 valence electrons. Fluorine has 7 times 2. So we have 6 plus 14, which would give us 20 valence electrons. Start with oxygen in the middle. 2 fluorines. Connect them each with 1 bond. And then we'll keep going. First trying to make the outer atoms happy with those 20 electrons. And we're going to use all 20 of them. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's what I do with the last 2. So I should have said we used 16 on fluorine, so we had 4 left, and those leftovers go on the central atom. And that works out well because that's exactly what oxygen wants. It wants 8 valence electrons, and that's what it has. So everybody's happy in this case. We're done. Move on to number 19. Number 19, boron has 3 valence electrons. Hydrogen has 1 valence electron multiplied by 3. So 3 plus 3 is 6 valence electrons. Now it's important to remember that boron is an exception. It does not want 8 valence electrons. I hope you remember how many it wants. Boron only wants 6 valence electrons. That's important to remember. All right, we're going to put boron here with 3 hydrogens. I'm going to connect it with lines each. And then we're going to count. That's 2, 4, 6. We're actually out of electrons at that point. We don't have any leftovers. Hydrogen can't do any double bonds. I mean, we don't have any extra electrons to use as double bonds anyway. So this is just the best we can do anyway. But it's also important to note that boron actually only wants 6 valence electrons. So the octet is actually fulfilled, so to speak, because boron has 6, hydrogen has 2, so both of those exceptions are happy. We're done with that one. Okay, look at PCl5. Phosphorus has 5 valence electrons. Chlorine has 7 valence electrons. Multiplied by 5. 7 times 5 is 35, plus 5 is 40. Put phosphorus in the middle. And then we've got 5 chlorines. That's a lot. So we're going to draw those kind of spread out. Chlorine here, 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 and then we're going to have one more down there. Okay. You could spread them out however you want to. All right, connect them. 2, 4, 6, 8, 10. And then we've got to keep going until we get to 40. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and then 40. So we've used all of the electrons. If you look at this, chlorine is satisfied. The outsiders are satisfied. That's what we want. And if there are extra electrons, they go on the central atom. Well, the central atom has more than enough. It has way more than it actually wants. It has 10 electrons instead of 8. But remember, this is a case of an expanded octet. You can have more than 8 on the central atom. Okay, then we get to ClF3. ClF3, we have 7 plus 7 times 3. That's going to be 28 valence electrons. Put chlorine in the middle, and we're going to have 3 fluorines. Okay. And you can draw them spread out however you want to. Okay. You have 2, 4, 6. We got to get to 28. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then 26, but that's still not enough, so we have to put another pair right here, 28. So again, you always do your math first. Available, find what's available, then we do the skeleton, then we make the outsiders happy. If we have leftovers, they go on the central atom, and then we check the number to see if all of the atoms are happy. If they are short, if they don't have enough electrons, we can do double bonds. But if they have too many, there's nothing you can do other than just put the extras on the central atom. So this one has 8 around fluorine. Chlorine has 2, 4, 6, 8, 10. But this is another expanded octet. All right, that's it for this section. We're going to do a little bit of organic compound nomenclature in the next video.